Hello everyone, welcome to Decision Tree. Tree-based learning algorithms are a broad and popular family of related non-parametric supervised method for both classification and regression. In a decision tree, every decision rules occur at decision node and with the rule creating branches leading to new nodes. For example, you can consider this point as a root node. Thereafter, a decision is made here and then it is broken in two another nodes. A non-parametric supervised method means in parametric you can actually understand that which captures all its information about the data within its parameter. All you need to know for predicting a future data value for the current state of the model is just its parameter. But in the non-parametric methods, you have to predict it even though input features or the parameters are not given properly. A branch without a decision rule at the end, let's say these one, are called as a leaf. So these are some important points in a decision tree. Now let's go ahead and see how this decision tree learns. Decision tree learners attempt to find a decision rule that produces the greatest decrease in impurity at the node. By default, decision tree uses a Gini impurity, and the formula of Gini impurity is like this. This process of finding the decision rules that creates a split to increase impurity is repeated recursively until all leaf nodes are pure or a custom cutoff is reached. And in this example, GT is Gini impurity at node T and Pi is the proportion of the observation of class C at node T. Alright, perfect. This is the visualization of a decision tree, and it is saying that how overall decision tree classification take place. For example, here we have, if we talk about the iris dataset, at the root node, we have a Gini index 0.667 and let's say samples total 150 and values are 50, 50, 50 for all the three classes. Alright. Then for the class Setosa, it try to break it. If it is the true, then that's mean it is classified with 100% accuracy. That's mean impurity is 0. That is the Gini index is 0 there. Alright. In the Setosa, so in the Setosa we have these 50 samples and there is 50 samples. Alright. And if it is not Setosa, then it could be a very versicolor and virginica. Alright, if you see. So at this point, then it will ask which one is this. Alright, whether it is versicolor. So if it is versicolor in out of these 50, alright, and if you see there, consistently this Gini index is decreasing. Here it's 0.66, now it is 0.5, and now it is 0.03, and there is 0. Whenever Gini index approaches to 0, that means impurity is approaching to 0, that means we are reaching at a final classification point. In this example, this tree is a small tree, but when this tree becomes large, I mean for large data points and large number of classes, then it will really become difficult to visualize this. So for this small number of classes, we can visualize it, but let's say if your data have 100 classes, then it will really become very difficult for the visualization of this tree breakdown. Alright, so this is the sample example for decision tree classification. This is just sample example. If you don't understand it, don't worry. In this In this course, we will take a separate lesson on which I'll talk about these step-by-step coding of a decision tree. So it is very small code. We will be using scikit-learn library in the Python, and we will be loading the data. Then we will be finally creating here a decision tree classifier, and then we will be training at the last step. Alright, perfect. So this is all about in this lesson. Thanks a lot for watching it. I'll see you in next lesson.